I'm long. You know what this is. You see me in such fine quality, epic, AP Environmental Science, educational videos such as water and salinization, what's the problem, and of what use are desalinization plants, part 4. Okay guys, here in this chapter we're looking at water pollution, and we know that water pollution is any chemical, physical, or biological change to the water quality. We know it harms living organisms or makes water unsuitable for use, whether it's agriculture or maybe we're using it for cooking, whatever it's going to be. Water pollution comes from point and non-point sources. So this is kind of a quick review. Point sources, they discharge pollutants at specific locations, like drainage pipes, sewer lines into bodies of water. Non-point sources are harder to spot because they're broad, diffuse areas. So a chemical or sediment runoff, logged forests, urban streets, parking lots, golf courses, and front lawns. Those are all examples of that. When we look at the causes of water pollution in order, agricultural activities, industrial activities, mining. Now the next slide, I make it really big deal. You guys need to know this for the AP exam, okay? I am not joking with you. This proves I'm not joking with you. Some people are going to ask how, doesn't matter, but you need to know this. Absolutely guaranteed on the AP exam. You should know about the oxygen sag curve. Now the idea behind that is you have a point of discharge, you're discharging stuff into the water, and because of the discharge into the water, there's stuff that needs to break down. Bacteria help break it down. The problem is that when the bacteria are breaking it down, they suck up the available O2 that's dissolved in the water. So what you are getting is a drop in the amount of dissolved O2, and then of course this is the distance downstream from the charge. So when it's a mild pollution, that's not too bad, but when you get heavier pollution, notice that the curve is getting steeper. Then it's the sag. Now remember, the idea behind the sag is like, that's the idea behind the sag. Need to know that for sure, okay? We talked about water pollution in streams and lakes, how they can recover. Okay, how do they do it? Dilution and biodegradation. Okay, the problem comes down to is if you overload it. It's not going to work if it's over polluted or the flow is restricted. And 1969 near Colby, Ohio, the Cuyahoga River caught on fire several times. There is no town of Colby, Ohio. But this is the actual photo in 1969. Here it's the black and white, and here is the color. So you can see the difference. And really nasty stuff there. I am not going to worry so much about this. This is just statistics for you guys, but it is certainly a problem in other countries as well. So much of the world's major rivers are polluted. Too little mixing and low flow rates make lakes and reservoirs vulnerable to water pollution. Well, what's the problem? Well, water flows not like the streams, or the streams is pretty consistent. When you're looking at a low flow rate like lakes and reservoirs, the water's not moving as much. And because it's not moving that as much, it's not giving a chance for things to become diluted, less concentrated, or, biodegradation. We're not getting to see that. So the water doesn't flow like streams. Stratified layers don't mix vertically either. Now, why would we care about this? And you should know this. Biological magnification of DDT and PCP, some radioactive isotopes, and mercury compounds. This is part of the problem just dealing with water pollution. We talked about eutrophication, natural nutrient enrichment of the lakes. Okay. Cultural eutrophication, man's impact because of agriculture, urban life, and industry. Here's the big thing you got to look at. Nitrates and phosphates. Those are the big deals that when they go into the water, they actually promote algae growth. The problem is, though, bacteria also reproduce because they have to break stuff down. The oxygen gets depleted, and what happens is, in the process, other animals die that are in the water, like fish, for example. That gets to be a bit of a problem. Okay? And again, this is just statistics as far as the EPA goes. Feel free to pause and write your notes there. Okay? The other thing about it is we can talk about man's impact due to agriculture, urban life, and industry. From the 1950s to now, the nitrate levels discharged from the Mississippi River into the Gulf of Mexico has tripled. What's being disrupted? The animal life and the nitrogen cycle. Bit of a problem. Dead zone in the northern part of the Gulf due to oxygen depletion. I'm just going, fine, and there's your homework, and yes, it's been put on the assignment center as of 2019, April the 8th, 2019. Okay, we talked about chemicals being put in the water, groundwater pollution. It's not easily cleaned up. There's a low-risk ecological problem, but there's a high-risk human health problem because a lot of people depend on the water from the underground wells. I got to see what my timing looks like. Oh, we're doing great. Okay. That's a problem. Degradable waste not cleanable as a flowing stream. Yeah, that's a problem. Groundwater doesn't flow like a stream does. The water moves less than 1/3 of a meter or 1 foot a day. That's not a lot, not for groundwater, and certainly to clean it up. Extent of groundwater pollution. It's serious in some places on the global scale, but we don't know much. The problem that we run into are nitrates again and arsenic. What are some of the problems that we have with pollutants? The NO3 mixed with the nitrates, so that's the nitrates that's mixed with the nitrites. NO2 creates organic material. It can cause cancer in living things and blue baby syndrome. Look that one up. Arsenic. Arsenic, World Health Organization, that's the WHO, the standard is 10 parts per billion. And I think I need to do something to show you guys about parts per million, parts per thousand, parts per billion. I need to do something to show you guys the concept of concentration. Long-term exposure in Bangladesh could cause 270,000 premature deaths due to cancer. What in the world do we do when we have this stuff of arsenic and water pollution? Well, the best thing is to prevent contamination. Well, this is kind of like a duh. It's easier to prevent something than it is to go and clean it up. It's also cheaper too. All right, let's keep going. We got to look at ocean pollution, okay? So with that, we got to get into how much pollution can the ocean deal with. The reality is we don't know because the ocean is so dynamic as a place, okay? It dilutes, disperses, and degrades all kinds of pollutants. Well, that's true. It does. It's pretty vast. But the problem is there's a limit as to how the ocean can clean the pollutants. If we're overloading the system with pollutants from the air, the streams, and the land, the ocean's not going to be able to clean it up, and thus the ocean becomes even more polluted. An analogy, and it may sound like a gross analogy for people, but you can get a toilet stuck. How do you get a toilet stuck? Typically, if you overload it with stuff and you expect it to flush down and be able to work its way through. Now, some people are going, ew, hopefully you're not eating dinner at this point, okay, or you're about to eat dinner, then I probably cut your appetite. But that's basically the analogy there, in a sense that the ocean, if it's not working, if it's overloaded, it's not going to work. But this is also true for rivers and streams. So this is a main concept, that there is a natural system placed in there, you know, imagine God doing this, that it naturally cleans things. But what happens when we overload it? Then it's not going to work. It's just not. That's like if I turned around and I said to you guys, we're going to have a test every day for the rest of the week. Okay, and no, there's no study guides. You're on your own. And it's not open book and it's not open note. That's kind of overloading you for the rest of the week. Tuesday, Thursday, Friday, since Wednesday we're doing that thing. Now, we have to look at coastal areas. How do the pollutants affect the coastal areas? Well, when you have more folks, more people, more development, guess what? You're going to have more problems. Okay, and that's when you start looking at harmful algal blooms, HAB. Okay, algal is another way of saying algae. Okay, nitrates and phosphates released into the water cause algae to grow. You know why? Because it's a natural resource for them. It's a natural building material for them. You'd say, but wait, don't they do the photosynthesis? Right, that's true. But they also need raw materials in order to be able to continue to build. Because, guys, remember, photosynthesis, your main product is food. But you still need some raw materials in order to make things happen. And where are they getting the raw materials? Nitrates and phosphates. And where do we find nitrates and phosphates? Well, in a number of sources, but a big one's fertilizer. Whether it's in the garden, whether it's on the golf course, whether it is on the lawn of some mall, it doesn't matter. If it's running off, and it's running off in large amounts, it causes the algae to bloom. It causes them to grow like crazy. Now the problem is they'll release toxins, both waterborne toxins and airborne toxins. So it harms sea life, fish-eating birds, it reduces tourism and poisons seafood. Well, how does it reduce tourism? It looks disgusting. One example of an algal bloom is red tide, okay? Where literally the entire place, it's red, okay, because of the algae bloom. Now, in Helsinki, in 1980, they did a treaty to reduce marine pollution. Well, let's get a little bit more into that. So here's some algal blooms that have happened. In the light blue here on this is off the coasts of France and the United Kingdom. Okay, this area here would be Brittany for those people who are wondering. Okay, and that's, you know, looking from the satellite. Now here, this is an algal bloom in the freshwater lake in China. This actually looks more like, you know, a green machine smoothie than an algae bloom in a freshwater lake in China. But that does happen. You get the right combination of materials and there you go. Now we got to talk a little bit about the North Pacific garbage patch. Okay, this is definitely one of the newer problems that have come out. In 1997, Sea Captain Charles Moore discovered 2 patches of plastic and solid waste swirling around in a vortex in the Pacific Ocean in 2 different locations. This is kind of scary, okay? And with that, this is the actual pictures of this patches of garbage that's there, okay? And there's 2 places, and the reason why they're there is because of the currents. And they're forming this vortex, and they're spinning there, okay? So you've got this spinning thing here, and it's pretty huge. This is not some little thing. This is garbage that, you know, everybody has thrown out, okay? This is so not cool. Okay. Now, what's the problems? And you need to be very specific. This is a pretty important thing here. There are tiny plastic particles mistaken as food by seabirds like albatross, fish, and other species. Now, keep in mind with the seabirds, they're not exactly the smartest, okay? They're the smartest. When it comes down to natural selection, they're found wanting. They got a low score on natural selection. Look. They're not going to know that, okay? So what happens is the particles get swallowed by them and they can't be digested. Because, you know, look how well plastic digests. Causes of death, starvation, choking, or poisoning. There is none of this in that, okay? It's bad. It's just plain bad. Now, part of the problem is that you also have fish that feed on the plankton. They also ingest, they eat these tiny pieces of plastic, and the plastic itself can contain PCBs, polychlorinated biphenyls, DDT, the pesticide, hormone mimicking BPA. All this stuff's going to have effects on those animals, and we need to be specific about it. That's why I put up the troll face up there, saying problem? Yeah, that's a bit of a problem here. Okay, I'm looking at my time, guys. Okay. Now the problem comes down to is these chemicals can build to a high concentration in food chains and food webs. Can it end up in your fish sandwich? Yeah, it can. And that's a problem about those chemicals building up, and that is a concern that they have with the fish. Okay, the fish is food, so we're polluting, and we're polluting our own food sources. Bit of a problem there. Okay, another problem we have is oil pollution. Big issue there, and I think I would want to hold on to that one, and let's stay here. So in terms of looking at the plastic, very important that you guys understand what's going on with the plastic. Okay, talking about the North Pacific garbage patch there. Okay, we also talked about eutrophication. Okay, we talked about the idea of algae blooms. All right, what's causing them? Nitrates and phosphates. All right, can oceans and rivers clean themselves? They can. Okay, they can dilute, disperse, and degrade all kinds of pollutants, but the problem is there's a limit. We messed that up. Okay, we also talked about the idea of groundwater pollution, again with the nitrates and the nitrites. Arsenic, that's another issue that we have. Okay, pollution of groundwater, why is that such an issue? Don't forget your homework, which is up on the My Assignment Center. Okay, cultural eutrophication, we talked about that. Okay, we also went and looked at polluting of waters and streams and lakes. We looked at developing countries. We looked near the town of Colby, Ohio at the Cuyahoga River. Okay, oxygen sag curve, should know that one. Okay, and major water pollutants and their sources. This would be a big thing, including their effects. Okay, and I'm going to stop here because, well, I've just run out about this. I'm long, and I wanted you to know those are the facts. Take care, and God bless you.